Okay, let us start. Let's continue. And at the last time, at the last moment, we have within our doc class, the symbol interface, talker interface, and the human class. And we state that the human class is both swimmable and a talker objects. But we state it by using the following syntax, especially after class declaration, we write here implements keyword and write the name of the implement interfaces that we want to implement. And we say that if we are a class, a concrete class which implements the interfaces, we are responsible to override all the abstract methods within the implemented interfaces. And this is the only responsibility of the given concrete class version. And let us do an example application together. Let's write a class with a name that main app. We try to instantiate some object from both the interface and the abstract class, human class. Okay. Our first object will be from the human interface, human class. And the name of the variable is the human and from the human interface class. And right here, new human. And in order to define a human, as I will say, we have two different constructors, especially one define a human with both in name and age, and one we only instantiate a name instance variable, and I want to use the first form of the interface. I say that the name of the human is the engine, and the age of it say that 32. And we instantiate our first human object. Let me instantiate another object from the dog class, which is also a swimmable object. Say that the name of the variable is also dog, and it starts the instantiation. And the dog will be also defined by the name and the type of the dog, especially we will use this constructor. And the name of the dog is say that the what will the name of the dog say? Mutlu. Name of the dog is Mutlu. The type of is that. Say that what will be the type of this dog? And bulldog say that. And we know that both human object and the dog object are swimmable. How can we sure about it, especially? These two distinct objects, in terms of behavior, will share a common method. It will share a common property, which is they are both swimmable, and that's why they can use the method of the swim. And also dog can swim. Yeah. And let me run this state. And you will see that it prints out engine can swim, which is the version that we implement in the human class, as you can see there. We have a swim method there, which implements it. And also the version that we override inside the dog class is also defined there. That's a dog with a name, Mutlu, can swim, and it prints out the text as you can see there. But human has another kind of functions, and human is also a talker. And that's why we can also call the method an abstract method, which is defined inside the talker interface over the given human object. And this is one additional property of the given human, and if I look at the output of the new statement, it prints out I am here since I can think of. And this is an additional property which belongs to the being a human object. And especially in this scenario, we demonstrate here is that uh, a class will implement more than one interface at the same time. And if that is a step, we need to go to the next idea that we need to know about it, and which is another feature of the given interface. And let me state this property of an interface. And this is the following. You cannot instantiate an object from an interface. Especially this is very important statement for us. And which is very reasonable, by the way. You cannot instantiate an object from an interface. We state that an interface is a collection of the constant and the abstract methods, and which means that all alone the interface cannot represent a real entity, and that's why it is very reasonable that you cannot generate a new object from a kind of concept which cannot be defined independently. And I want to say the following in terms of syntax in Java. And if we want to instantiate an object from an talker interface, say that, which is an interface. And like this one, we know that all by default an empty constructor will be generated by Java compiler for all the classes. But talker is not a class, which is an interface, by the way. And as we stated earlier in 1 minute ago, you cannot differentiate an object. You cannot instantiate the type talker, because which is an interface. And we will give a similar example. And we have another interface called a swimmable. And call that I want to instantiate an object from with a name swimmer, and as follows. And which is also not doable, which is not allowed by Java. And this is the rule that we must remember when we work on interfaces. You cannot instantiate an object from a given interface. Okay, this is the first rule that you need to define related to interfaces. So far so good. Not swimmable, sorry. We need to remember this rule. There will be trick questions related to this issue during the exams or an interview, especially if you're going to apply some position related to Java and you need to know about the interfaces, and you don't forget that you cannot instantiate an object from an interface. Okay, but there is an exception there. And remember the substitution principle. We state that whenever an object from a superclass is expected, you can use a subclass object. And I said that it is also related to the concept of polymorphism. And by words meaning the polymorphism means of having many forms. And let me explain how we can define a variable which has many forms exactly. And we have a swimmable interface and the talker interface in our hand, and I want to instantiate an object from the talker interface. Let's follow. But and if I with the semicolon, especially what means that we generate a variable with a identifier talker, and which refers to talker interface. And but I stated in the previous statement, you cannot instantiate a talker object. But I will do the following. I will assign this reference to talker to an object which is a concrete class implementation, such as a human. The talker will be assigned to an object from a human class. Say that I want to define an object and give a name to it, say Aisha, and which is also doable. Sorry, I'm going to use second constructor inside the human class to only assign the name of the given user, human, and which is allowed by the Java. Then over the talker object, I will call the talk method. And if I run this code, you will see that there is no error given here, and it just prints out I am here since I can take off. What is happening here is seems very awkward at first glance, but which is very good advantage when creating a programs exactly. What is happening here is the following. I generate a variable which is designed to refer a talker object, but a talker is an interface. That's why also we state that you cannot have an object from an interface. But in the next statement, in line 16, we assign the talker reference to the new human object with a name Aisha. But human object is a concrete class. Human is a concrete class, and we will use this object. But also the human is a kind of talker by its statement, by its declaration. That's why I can use this reference, the talker reference, to refer to the human object, because the talker can refer to a human also by the statement. And we will call this talk method, which is stated in the talker class, like this one. But I know that the human object is also swimable one. And in that sense, I assume that I can also call the swim method over the given talker reference in the given scenario. But if I try to call the swim method and after dot notation, you will not see any reference to swim method as you can see there. But human is a swimmable object, and I can call the swim method over it, as we have done already. But we couldn't call this method now. What is happening here is very awkward at first sense, but which is also very reasonable. Why which is very reasonable? Let me explain it to you. Okay, let me turn our attention to talker interface there. And I know that the talker interface has only one abstract method called as solve. And which means that any object that will refer the talker interface, which will only call the talk method, whether or not, which is human or dog. And our variable, the talker, which also talker interface, which means that it only calls the method within the given interface. That's why we will only call the talk method over the given talker reference. We cannot call a method which belongs to the human class or the other interfaces which assign it to it, and which is also an important issue there. And which means that superclass references will not invoke the subclass methods in that sense. In other words, this is also important in both inheritance and interface concepts. Put your idea into your mind, and there is no problem with it. Especially we use the superclass reference in that sense, and over the superclass reference you cannot call the subclass methods. And also another interface methods, doesn't matter. Which is another issue inside this kind of references. And the next thing we are going to discuss is going to be the polymorphism in that sense over the given talker reference. And let me look at the following statement, and which will not create an error also there. I want to assign our talker variable the new variable, and which is going to be a new doc object, new line. And thus I call this name of the doc is preferred. And I say that the type of his data what will be husky. I know this is not a good name, but there's a problem as you can see there. Why? And which is an expected problem, by the way. Why? Because because of the following reason. I know that the doc class does not implement. It doesn't implement the talker interface. It only implements the viewable interface. That's why this statement is a wrong one. Only human keys is a talker one. But if I do the following, let me make an example. Say that call that swimmer. New doc prefer husky, type of is husky one. You can call the swim method, which is defined inside the swimmable interface and which is overridden by the doc class, and it will print out here a doc with a name prefer can swim, which is also similar to this example that we done here. And let me change the scenario a little bit there and assign the swimmer reference to another object in the next statement, and which is going to be the human one. And say that the human is Mahmoud and age is that 35, like this one. But which is very interesting in that sense. In the line 18, our swimmer variable will refer to the doc object, but in the line 20, our swimmer reference, swimmer variable will refer to the human object. The same reference will be used to refer to distinct objects. In that sense, the variable swimmer is called as polymorphic, and which means that the swimmer object variable will take two different forms. In one statement which behaves like a dog, in another statement it behaves like a human. I can call the same swim method over the swimmer reference again, as you can see there. If you run it there again, you will see that in the first statement it prints out the purple dog with a name purple can swim, but with the statement in the line 21 it prints out Mahmoud can swim, and this is the version which is overridden inside the human class. In one line it behaves like a human, in one line it behaves like a dog. And that's why the swimmer variable referred as polymorphic, which means the having many forms. Okay. which is very great advantage while developing a program. This is one example of the polymorphism, and which is an example of compile time polymorphism in that sense. There are two kinds of polymorphism exists. One kind of is called as compile time, where the form of the object will be determined during the compile time. The second type of polymorphism is called as runtime polymorphism, where the object behavior will be determined during the runtime of the given program. And this example will demonstrate the compile time polymorphism for us. Okay, so far so good. Do you have any questions so far? Would you want to ask anything else to me? I know this is not very easy concept. There are too much details behind there, but we need to follow some statements here that we written there, and especially which requires some practice to get use of how does this mechanism will be, works exactly. But I want to make sure that you get how you will generate this kind of scenario on your own. Please don't hesitate to ask any question. Essentially, these ideas will be common for all programming language which is based on object-oriented programming design, and which is applicable to all those scenarios in real-life scenarios that we've seen so far in real applications, whether or not it is a desktop app, mobile app, web app, doesn't matter so far. Okay. Do you have any question? Can you get the idea here? I will be happy if you get a response from you, by the way. You can ask your question in Turkish. Okay. If you doesn't have any response from me, I will go turn back to slides. And what are the other things that we need to do? Okay. Maybe at this point I will talk about an interface, a kind of interfaces which is defined in standard Java API. One is called as the comparable. And remember that while using the string comparisons, we use the compare to methods. Especially, we know what does it mean, but this compare to method is not only defined inside the string class, which is defined in an interface and which is implemented by the string class in reality. Especially what is happening, the string class implements the comparable interface, giving us the ability to put strings in lexicographic order. And if you want, a class implements the comparable interface, which means that I want to make one method inside my class, and I want to assure that the given two objects is equal to each other or not. I will need to implement a comparable interface in general. Let's apply this inside our doc. I want to make this doc class also implement a comparable interface, which is a standard interface defined inside the Java API. Comparable. And you will see that this is highlighted by the yellow. And now what I need to do, I need to add unimplemented method, which is name is the compared, as you can see there. And normally the compared to methods return 0, and which is a return type which is an integer one, if you look at this one. For the case of the strings, especially if they're compared to methods, returns an integer, and which will be negative, and then compare the given two string objects with each other if they are not equal to each other. But I want to make sure that if the given two doc objects, and let me cast this the argument to doc object in the next statement as follow doc, and we will do explicit casting as follows. RFA 0. Okay. Then to be sure that the given two doc is the same doc, what should I do? I need to write some comparative statement here. Maybe I will use switch case if, and the best option will be in an if. For example, and I want to check that name of the given doc is same as this doc, and this name is equals or not. This dot name equals to name of the given argument doc. And then also the type of this doc though must be matched to be sure that the given this two doc object is the same. And type of the given doc is equals, and which will be the doc dot type. And if that is the case, return 1, and otherwise else return 0. Means that these two docs are not the same doc, especially. And what we do here is that we overwrite the compared method, which is defined inside the comparable interface by Java, and we implement this one inside our doc class. And I can call any methods over it, such as that I know that it's the statement that at line 20, or maybe which is not a doc one. Okay. Okay, we will go to this step later on. And there is one standard interface which is defined inside the class, which is comparable. It is better to know about it. Also, another interface which is standard in Java is the iterator. You can remember the iterator interface from the collections framework, as you will guess. And we instantiate some iterator object over the given collection member, such as over the array list. We call the iterator method and which returns an iterator object. Especially iterator is a kind of interface also. And inside the iterator we have some method, remember, as next, to check that true or false, whether or not there is a next item in the given list. Or we have the next method, which returns the next item in a given list. Also, we have the remove method, especially we remove the object false return by the next method. These are the common methods for implementing written inside the iterator, and which will be implemented inside the classes which implements the iterator interface. Such as we have concrete implementation iterator, which is list iterator, which is generated for the given list, the array list objects also. There are also another interface called as iterable, and which provides an iterator, and also the array list sets or the collections. He wants to generate an iterator, remember, and which should implement the iterable interface, which means array list, linked list, hash set, tree set, or all of them implements the iterable interface. And that's why they can return an iterator object over the calling the iterator methods. An iterable object can be processed using for each version of the for loop. Note that, for instance, an iterator has methods that perform an iteration. An iterable object provides an iterator on request, and which generates an iterator. Iterable generates an iterator, especially, which are the real life examples where the interfaces are make the use of when we develop a class, especially, which are standard part of the given Java API, iterator and iterable. Especially you will see these two common interface name in other programming languages such as Python. There also exist. You can also see this kind of scenario there. But this is not the only feature that we see in the importance of the iterators there. And there are additional benefits of using the interfaces. And what can it be especially? Let me show it to you. And we have already written a symbol and compatible interfaces there. And we know that both human and the dog class implement symbol interface. So what is the next thing that we can do with the symbol interface? And turn back to our main app, and I will add a method here inside the main app, and I will call this inside the main method. I will call the static. I will create a method which is static one, return void, and that iterate. Call the method name is iterate swimmable, and which takes an argument of array of swimmable objects. Let's call as this argument as objects. The name of the method is given here, which is iterable, iterate swimmable. Go over each item inside the given array list and call swim method over them. Okay, I will write a for loop for there, and which go over each item inside my array. And I call the swim method over each item. That's the only thing that we are going to do. And inside our main app, we have some swimmable objects such as dog, human, and also the swimmer. We have 3 swimmable objects there. Now I want to generate an array inside my main method, which stores the swimmable references. Then we call this array as items. And the elements of this array will be going to the human dog, and this last one is going to be swimmer. At first glance, these 3 different variables comes from different kinds. They all have swimmable objects. That's why we can store these 3 distinct types in the same data structure. And the next thing that I'm going to do is call this the following iterate swimmable method. and then pass the items array as a parameter. And the next thing I am going to do to call this run method. And then we will see that this statement iterates the will call the swim method for each object inside my array one by one and prints out on the screen the messages that we define inside them. And why do we need to do this? Why we see this example in this demonstration? Especially what we see here is that all distinct objects which is generated from the same interface can be processed inside the same method, whether or not which is dog or human. It doesn't matter because they are all implemented same interface. They can be processed by the same method, which is another great advantage for the programmer. You write a program and you write a method, and this method will process more different kind of items at the same time. This is another good advantage of using the interface concept. Okay. Is there any questions so far? Arkadaşlar dersi takip edebiliyor muyuz? Problem var mı? Burada mıyız? Okay. Okay. There are some examples listed in the presentation. I suggest you to work on them on your own, and the code parts also given here. Code snippets are described in here, and there are two different examples given there. Well, one of the examples is here is that we have defined an interface called as measurable, and there are two concrete classes called as bank account and country, which implements the given measurable interface. And then we have another class which works on the measurable objects, and which includes a method which is able to manipulate the measurable objects. And this is an example given here. We have data class. Inside the data class we have a method called as average, which takes an array of the measurable objects and which will generate the average value for the given measurable object, such as we have list of bank accounts or list of the countries, and which will return the common measure of the given average of the common measure for each distinct type of the given measure objects. This is a kind of example that we have seen so far. I suggest you work on them on your own, and the codes are given also there. But up to now we see that there are some similarities between the concept of inheritance and the interfaces, and which is kind of inheritance, but it is not exactly an inheritance. And these are the list of differences between interface and inheritance. And suppose that we have the following interface with a naming, and inside the naming interface we are defining an abstract method called as getName. And then in the next statement we state that a class can implement more than one interface, which is the case we have already seen an example. And you will see that a class with a name country is defined, which implements both measurable and the name interface in this declaration. However, we learned that the class can only extend or inherits from a single superclass. You will only have one superclass. By the way, a class can at the same time implement more than one interface and inherit from one class at the same class declaration, which is also doable, by the way. I will make an example of it for you. An interface specifies the behavior that an implementing class should supply, and which means that we don't define the body of the method inside the interface. That means that we don't define functionality for a given method. But if we consider this inheritance, we will inherit the methods of the superclass directly and we can make use of it. Which means that a superclass provides some implementation that a subclass inherits. And develop an interfaces when you have the code that processes objects of different classes in common way. And this statement is related to the previous discussion that we done already. Okay. Okay, do we have any helpful feature for us? Especially, we have done this kind of example together up to now. That's why I skipped most of the slides there. We have also seen the comparable interface. Do we have additional? There are some self-check questions with the given answers. Okay. Okay. Let me check is there anything here? Okay. Finally, I will do one more example which summarizes all the things that we do here up to now. Okay, what we can do next is the following. I will both use the concept of inheritance and the concept of interfaces together. Especially we will use the inheritance concept and interface together in the next example. For this job, I will draw first the diagram, first the scenario that we are going to do. Firstly, new blank diagram. And this blank diagram start with very simple class and the interface declaration. Sorry, where is it? The mail is here. And I have a class with a name soldier. Okay, this is going to be our superclass in that sense. Then each soldier will have a name, and the whose type is going to be a string one. And also inside the soldier class, say that we have a method there which is called as take action, and it doesn't take any parameter, and the return type is the void one. Then I will implement two common interface which we have already done, swim, and the name of the interface will be the swim one. We have written already. Sorry. And inside the swim interface, we will have a method called as swim, which is an abstract one by default. You cannot define the method body inside the interface. Don't forget about it. In a similar way, we have another method, another interface, which is called as the runnable. And I know that soldiers are in the runnable interface. We have a method called as run. Okay. Then I know that the soldier is both runnable and swimmable objects. And to represent this relation, we use different kind of error. The body of the error is a dashed line, and the arrow line is like this way, and then also represent UML by this way. And this is a relation between both runnable and swimmable interface. But we will have different kind of soldiers, such as with a kind of soldier called as commander. And then which is originated from the soldier class, which is inherited from the soldier class. And this relationship which is used the straight line, and arrow head is the empty one. Sorry, not like this one, which will represent by 0. And how we can write a commander class in a given scenario. And this is the problem that we want to solve. And a commander will have, say, the additional field experience, which is the instance variable which belongs to only the commander, whose type is an integer one. And also the commander method has another special method which only belongs to the commander to command, give order, let me say, and which accept a string argument, and whose return type is going to be void one. Okay. This is the scenario that we are going to draw. I will not give any breaks, sorry for this. We will finish this part and the lecture will end today. And how we can do this? In the given scenario, we have already written the swimmable interface. The next thing that we are going to first do is the rewriting the runnable interface, which is also going to be a very simple one. Right click on the package and choose the interface here, and write the name of the interface in the opening box, which is runnable, and click on finished. And inside the runnable interface we have one abstract method called as run. Public abstract and run. Name of return type is void. Name of the method is run, and which doesn't take any parameter also. And we have finished first job, and we define an interface. And remember, the interface is a collection of abstract methods and constants. We have only one method in our scenario, and we have also swimmable interface, which is in the same manner. And we need to write a new class called as soldier. Okay, I said soldier, probably soldier. In the soldier class, there is an instance variable called as name, which is going to be a private one. Okay, and we will add a constructor here. Go to source tab, click on generate getters and setters. Sorry, generate constructor using fields, and click on OK. And generate getter and setter methods for the name instance variable. Again, go to source tab, click on generate and getters and setters, select all, click on OK, and that's finished. But our job started yet. And what is going to be next is implementing both swimmable and runnable interface for a given soldier class. How we can achieve this, and which is very simple one. And after in the class declaration line, write here implements, and after the implements word, write the name of the interfaces one by one, which are swimmable and runnable. And especially as a concrete class which implements the given interfaces, I am responsible to override all unimplemented methods inside the given interface, which are run, and inside which is inside runnable, and swim inside swimmable. To go to the list of unimplemented methods, either you will click on add unimplemented methods there, or go to the source tab at the top menu and click on generate override implement methods option there. And you will see the list of the interfaces which we implemented here, and which are the abstract methods swim and run. And click on OK, and these methods are with empty body are overridden in our concrete soldier class. And the next thing that I am going to do is write the body of each overridden methods, and so it prints out simple message on the screen. I can run with speed less than kilometers per hour, which is very fast, man. And swim, it prints out I can swim with speed 5 meters per minute. Say that minutes per, maybe say that 1 kilometer per hour. I don't know which is a fast one or not, I'm not sure yet, but not a bad measure. Okay, the next thing we are going to do, let's define a subclass, which is a subclass of the soldier called as the commander. Okay, let me save this code and create a new class called as commander. I know that the commander is a kind of soldier. How we can state this? As at the class declaration, start with the extends keyword and the name, write the name of your superclass, in that case which is soldier. The soldier class has some field called as experience. That in terms of years, it is going to be private one and it is in integer. And the next thing we need to do, write a constructor for a given commander. And then what I need to do, this commander constructor will take a name of the commander. And then also will be the years of experience, also additional parameter. But I write this constructor in such a way that this way. The next thing I need to do, especially we read the name of the commander from the constructor, and this name variable, which is defined inside the soldier class, I think, but we didn't define it, sorry. Okay, which is written here, sorry. Let me cut them and paste below at the end of the getter setters, and which is defined, as you can see, in the my super class, which is name. But you will ask the following question: you define this name variable as a private one, and since this is defined as private, this variable cannot reach directly inside the commander class. At the first glance, your response will be a correct one. But don't forget that I will refer to superclass constructor, which is soldier, inside my class using the super keyword. And right here super, instead of soldier, I write here super and pass your parameter as an argument, which is name in that case. And then over the commander, the next thing I am going to do, assign the experience of the given commander initially 0. The first constructor that we write here is this one. We will add more constructors to this list, but let us right now, for simplicity, skip this point and then define another method which also only belongs to the commander give order. Okay. Void give order, which accept an argument to the order of the commander, and it's just a simple text message again. Commander with a name. How we can get the name of this commander? This does get name in that case, especially since the name variable within the soldier is defined as the private. You cannot call it directly over the dot notation using this reference, but you will call this private name variable using the getName method instead of referring it directly. Says the message to order. That's the only thing. It is very simple method again. Oops. Okay. I think everything is good right now. Do you have any question? Is there any question up to now? Okay. Let us write some test program. Click on new and create class, new class, and call that test step again. Don't forget the put main method. I'm going to instantiate a commander object with the variable name commander and new commander. Say that our new commander is the ACM. And then look at the methods that we call over the given commander. Look at the list of the methods. We have the run. We have the swim methods there. But the swim and the run methods comes from the which class, especially which comes from the soldier class, as you can see there. Soldier. Especially where we see here is that inside the soldier class we override both run and swim method, which comes from the swimmable and runnable interface, which are two distinct different actions which will take off as a soldier. By the help of the inheritance, we make also the commander is both runnable and the swimmable objects. By the way, it automatically implements the runnable and the swimmable objects by means of the inheritance, because commander is a kind of a soldier. Commander is a soldier also. That's why commander is both swimmable and runnable object. That's why whatever commander do is, especially whatever swimmer do, commander also do. And that's why I can call the swim method over this commander object. I can also use the same commander object to call the run method. And also I can call give order method, which only belongs to the given commander. Go ahead, please. And if we run this program, it prints out I can swim with 1 kilometer per hour, I can run with speed with 10 kilometer per hour, and the commander assembly says to go ahead. Especially we will see the power of this approach, these two distinct approach. We both use the concept of inheritance and interfaces. Especially what we do here is that our soldier interface class implements swimmable and runnable interfaces at the same time, and also we define another subclass of the soldier called as the commander, which is extension of the soldier in other words, which also use the both swim and run method, and which also makes the commander objects both runnable and swimmable references by means of the inheritance. And the intention of this example is to give you how these two concepts makes our programmer life easier and makes them more flexible in program development. Two simple features makes your life very easy in that sense. That's it. I will stop at this point today. Next week we will continue with these examples, with new examples, and also we will discuss the abstract class concept together. And if you don't have any question, I thanks to people who attend this cover course during the weekend, and I will upload all these recordings to the YouLearn. Especially I will share the links of the recordings with you. I will upload it to the Drive folder, and this is the best way to watch them. And thanks for your attendance and listening. Let me stop here.